A neural network for custom methods for inventory management in the supply chain. Purpose and objectives of the research. Purpose of the researchers is to develop an artificial neural network and focused methods in the supply chain to improve the focused accuracy. Objectives of the research. Analyze existing forecasting methods. Propose an forecasting model. Choose a criterion for evaluating the effectiveness of a forecasting model. Propose a method for determining the values of the parameters of the forecasting model. Conduct a numerical study. Problem statement. Let the training set be given for the focus. Then the problem of improving the focus accuracy for the model of a time delay restricted voice machine, where x input vector, W vector of parameters, is presented as a problem of finding for this model such a vector of parameters that satisfies the criteria. Forecasting model based on the time type 1. Positive phase. Initial moment time. Initialization of the state of the visible input neurons of the time delay. Initialization of the state of visible input and output neurons. Calculation of the probability of transition of hidden neurons to state 1. When synaptic weights between the visible input layer taken into account unit delays in the hidden layer. Synaptic weights between the visible output and hidden layer. Therefore, have neurons in the hidden layer, the number of unit delays for the visible input layer, the number of neurons in the input layer, the number of neurons in the hidden layer, the number of neurons in the output layer. Computation of the state of hidden neurons, where standard uniform distribution on an interval. Negative phase. Calculation is the probability of transition of visible output neurons to state 1, where thresholds have neurons of the visible output layer. Computational of the state of visible output neurons. The result is vector. Forecasting model based on RMM type 2. Positive phase. Initial moment in time. Initialization of the state of the visible input and output neurons of the time delay. Initialization of the state of visible input and output neurons. Calculation of the probability of transition of hidden neurons to state 1, where synaptic weights between the visible input layer taken into account unit delays in the hidden layer, synaptic weights between the visible output layer taken into account unit delays in the hidden layer. This was have neurons in the hidden layer, the number of unit delays for the visible input layer, the number of unit delays for the visible output layer, the number of neurons in the input layer, the number of neurons in the hidden layer, the number of neurons in the output layer. Computation of the state of hidden neurons, where standard uniform distribution on an interval. Negative phase. Calculation of the probability of transition of visible output neurons to state 1. Computation of the state of visible output neurons. The result is vector. Criterion for evaluating the effectiveness of a neural network forecasting model. For training the RMM model, a model adequacy criterion was chosen, which means the choice of such values of parameters which deliver a minimum and the mean square error, the difference between the model output and the desired output. The training of the RMM model is subject to criterion 1. Experiments and results. Discussion. Recurrent neural networks with deterministic neurons are more efficient than non-recurrent neural networks with deterministic neurons. Neural networks with stochastic neurons are more efficient than neural networks with deterministic neurons, and Grygorian type has the highest forecast accuracy. Conclusions. To solve the problem of improving the forecast accuracy in the supply chain, the existing forecasting methods were investigated. The studies have shown that today the use of artificial neural networks is the most effective. To improve the quality of the forecast, a stochastic neural network RBM was chosen, modified by the introduction of cascades of single delays in the input and output layers. In the course of a numerical study, the structure of its model was determined. The experiments have shown that with 16 hidden neurons, the value of the mean squared array does not change significantly. The selected network gives forecast results with a minimum deviation. A method was proposed for determining the values of the parameters of the proposed neural networks forecasting model based on the good technology of the parallel processing of information. This made it possible to ensure high speed and accuracy of the forecast. The proposed approach can be used in various intelligent forecasting systems, for example, in supply chain inventory management system such as MMP, and in production, where forecasting plays an important